Hello everyone. Today we are going to be graphing some new types of functions that we have not done before in Algebra 1. So you are going to need your notebooks there with your graph paper and also maybe a calculating device and something to write with. Today we're just going to do a bunch of examples on how to graph these things called absolute value functions or absolute value equations. You need to write each example down. Okay, let's start with example 1 here. We are going to graph y equals absolute value of x. Now, you may remember back in Algebra 1 when you first started graphing lines, at the beginning, before we taught you some of the shortcuts on how to graph lines and what clues to look for, we used to graph lines by making tables of values. And there's nothing wrong with that. So we're going to start graphing these using the table of values today. So the table of values is something that's going to help us generate this graph. When you set up a table of values, you may remember from Algebra 1 putting values into the x part of this table. So choosing x values. Sometimes we chose values like 0, 1, 2, and then we maybe chose some negative ones for variety. And then we would plug these into the original equation to generate those y values. So if I take a look at my original equation, the equation says y equals absolute value, and then there's an x. Well, in this case, I'm going to put -2 in where the x goes. So the y value, that would be the absolute value of -2. Well, that absolute value turns into a 2. My y value is 2. And I do the same thing, plugging in x values all the way across. So what if I plugged in -1 where the x goes in that function? Well, then the absolute value of -1 would be 1. And what if I plugged a 0 in? The absolute value of 0 is 0. What if I plugged in the value 1? So if x is 1, the absolute value of 1 is also 1. And the absolute value of 2 remains 2. So if I take a look at what kind of picture this makes, or what kind of graph we've generated, be careful when you plot those points. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. We've created a V shape. All absolute value graphs will have this same general shape. It's not a parabola, it's not a U shape, it's a V shape. V for absolute value, if you want to remember it like that. Now on this V shape, there's a place called the vertex. The vertex will always be that bottom or pointy part of the V, or the graph. That vertex spot is going to be important to us. It's going to be a place we want to find at the beginning of our graph. You see underneath my table of values, I have the words vertex, domain, and range. These three things are going to be a part of our graph today. We're going to need to state these three things. The vertex in my graph is located at 0, 0. Now, domain and range are relatively new to us. It's been a while since we talked about them. So basically, the domain is a description of what all the x values are doing, or what all the x values could be on this graph. And the range is discussion about the y values. I'm just going to write a general description, and later on in the year, we're going to do things like interval and set notation, but for right now, we're just going to write a general description. The domain values describe the x values. In our table, we chose x values from -2 to 2. However, I could have chose any numbers in the world I want. I could have plugged in -3, -10, -1.9, whatever I want. So that means the domain is all real numbers. X values can be all real numbers in the world. Now, rather than write this phrase out all the time, there's a symbol that represents all real numbers. It's an R that has a double line going down like so. That's the symbol for all real numbers. And our x values, because we could plug in anything we wanted, we can say that all real numbers could have worked for x. Now my y values, my range is a little bit different. If you see what's going on in our table, will we be able to get any y value possible in that y part of that table? Well, let's take a peek. See how the y values went from 2 to 1 to 0, then back up to 1, back up to 2? And if you take a look at the graph, there's a low spot, and then my graph comes back up. This is another way of looking at that range. Basically, the range, the y values, are going to be greater than or equal to 0. Because in that table, they went down to 0, but then they started coming back up. We would never get a negative y value here because we're taking the absolute value. So this is an example of graphing an absolute value, making a good table, and then talking about the key parts that we're going to be looking at, the vertex, the domain, and the range. We're going to do 3 more examples here. And each one you want to make a table, sketch, and do vertex, domain, and range. Here's example 2. Once again, we're going to want to make a table of values. Now be careful, caution, you can't just choose any numbers you want in this X column right here. While we did that when we graphed lines, remember that my absolute value is a V shape. And if I'm not careful, I might only see half of the V and not know that the other part may be way down here. And if I only graph or choose numbers that I like, I might only see this part and not the rest of that V. Because of that, we want to be very careful as to the values that we choose in that X column. We want to choose ones that will provide us with the vertex and the 2 sides so that we can see both sides of the V. Now remember in that last example, our vertex was located at 0, 0. So to figure out what number will be our vertex, what number will start in the middle of our table, think about what X value zeroes out our absolute value or makes this become 0. When does X plus 3 become 0? When X is negative 3. So we're going to place negative 3 in the middle of the table because that guarantees us that we're going to see the vertex and both sides of the V. So because we started with negative 3 in the middle of the table, we're going to use negative 4 and negative 5, as well as negative 2 and negative 1. And once again, we're going to plug these values into the given equation, y equals absolute value of x plus 3, subtract 4. And we're going to plug it into that equation so we can find those y values. So this first one would look like absolute value, the x is negative 1. And if I calculate this, negative 1 plus 3 is 2. Absolute value is still 2. Subtract 4 is negative 2. Then I'll plug in negative 2 into the x in that equation. Negative 2 plus 3 is 1. Absolute value is still 1. Subtract 4 is negative 3. Then I'll plug in the negative 3. Negative 3 plus 3 is 0. Absolute value is still 0. Subtracting 4, like the equation says, gives me negative 4. Now I'm going to plug in negative 4. Negative 4 plus 3 is negative 1. Careful now, absolute value of negative 1 is positive 1, minus 4, negative 3. And one more, negative 5 plus 3 in the absolute values, then subtracting 4. Negative 5 plus 3 is negative 2, but then absolute value becomes positive 2. Subtract 4, negative 2 for my answer. So again, we'll go over our graph. We should expect a V shape. So negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, negative 3, negative 5, negative 2. I see that absolute value graph emerge. There he is, arrows on either side, and we can now identify the key phase. The vertex, again, is this bottom part. That's our vertex. The bottom of the V, or the side, or the place where the 2 sides come together there. So negative 3, negative 4, oops, is my vertex. Now domain and range again. Domain again is all the x values. So let's think about our x values. Could we have plugged in anything we wanted in the world and still found this V shape? Sure, I guess we could have plugged in negative 10 or negative 8 or negative 7. It would have taken us longer to see this V emerge, but we could have. So the domain, again, is going to be all real numbers. Remember that R represents all real numbers. And then the range is a description of what the Y values are doing. So if we look at those Y values again, sometimes people like to look at the graph, sometimes people like to look at the table. Looks like I go from -2 to -3 to -4, then back up to -3, then back up to -2. So it looks like my Y values are going to remain greater than or equal to -4. They go down to -4, but then they pop back up. So all the Y values I would ever generate in my table would be ones that would be greater than or equal to -4. Let's try a third example. Here's another one. We're going to graph the function y equals absolute value 2x plus 1, and then subtracting 4 again. I have my table of values, and we're going to find vertex, domain, and range. Now again, to find that middle part, where we put what x value, we stick right in that middle part to make sure we get our vertex in the middle like we want, so that we don't have to graph 20 different points to find the absolute value graph. We zero out or think about what value makes the absolute value turn into 0. So way up here, I'm going to take that 2x plus 1 and think about when does he turn into 0? Well, if I subtract 1 and solve that, it looks like when x is -1/2, that's when that absolute value will turn into a big 0. So -1/2 needs to go in the middle of my x column for my table. Now, just because that's a fraction doesn't mean we have to choose fractions on either side. We can go to whole numbers. -1/2 is in between 0 and -1. So we can choose whole numbers here, and then I'll get bigger here, and then I'll do one smaller there. It's just that that vertex or that middle spot needs to be -1/2. And now we're going to plug these values in once more again. So I'd have the absolute value, 2 times -2 plus 1, subtracting 4. That'll give me my y value. 2 times -2 is -4, plus 1 makes -3. Absolute value is +3 minus 4 is -1. Now I'm going to plug in the -1. 2 times -1 is -2, plus 1 makes -1. Absolute value makes +1. Subtracting 4 makes -3. Now I'm going to plug in -1/2, or -0.5. 2 times -1/2 plus 1 minus 4. 2 times -1/2 is -1, plus 1 makes 0. Absolute value of 0 is still 0. Subtracting 4, -4. Okay, now I'm going to plug in 0. 2 times 0 plus 1, subtracting 4. 2 times 0 is 0, plus 1 is 1. Absolute value of 1 remains 1. Subtracting 4 is -3. And last but not least, 2 times 1 plus 1 in absolute values, and then subtracting 4. 2 times 1 is 2, plus 1 makes 3. Absolute value remains 3. Subtracting 4 makes -1. So now if we go to graph this absolute value graph, and we go to take a peek at what's going on right here, -2, -1, -1, -3, -1/2, -4. Okay, careful on that one. 0, -3, 1, -1. There's my V, or my absolute value graph. Again, where is the vertex? The vertex is at -1/2, -4. That spot right there. The domain, we could have plugged in any x value we want. The domain is all real numbers. Again, you can write it out like this, or use that symbol. And the range is a description of what's happening with the y's. And again, looks like the y's are greater than or equal to -4. -1 to -3 to -4, and then back up. So it looks like they get the lowest spot there is -4, and everything else is going to be greater than or equal to that spot. All right, our last example. Here we have y equals negative sign, absolute value of x subtract 2, and then plus 3. So again, we're going to make a table of values. And again, we're going to find this middle x value here that we need. So inside my absolute value, x minus 2, when does that become 0? What x value makes that become 0? When x is 2, that would become 0. So I'm going to have 2 in the middle of my x column, some numbers bigger and some numbers smaller. And then we're going to plug them in to that absolute value equation that was given. This one's a little bit harder to do via video, so I'll try my best here. Negative sign, I'm going to plug in a 0. I'm going to start inside the absolute value. 0 minus 2 is -2. But then when I take the absolute value, it becomes +2. But then I have to stick that negative sign back on it and then add the 3. So it becomes +1 for my final answer. Okay. Then I'm going to repeat the same thing, but now I'm going to plug in the 1. Negative sign, 1 subtract 2 plus 3. So 1 subtract 2 is -1. Put the absolute value on it, it becomes +1. Multiplied by the negative that's in front, or -1, plus 3 becomes 2. And now I'm going to plug in 2. 2 minus 2 is 0. Absolute value is still 0. Negative sign on 0 is still 0. Plus 3 is 3. And now I'm going to plug in the 3. 3 minus 2 is 1. Absolute value is still 1. But now I have to multiply by a negative, so it becomes -1 plus 3 is 2. And I think you can maybe guess what's going to happen with 4 here, but we'll see. 4 minus 2, there we go. 4 minus 2 is 2. Absolute value is still 2. Put a negative sign on it, becomes -2. Plus 3 is 1. Were you right? Probably. Okay, let's graph this thing. 0, 1 is 1 point. 1, 2 is another point. 2, 3. 3, 2. 4, 1. This is still a V shape. He's just a little different. He's an upside down V shape. And in the next day or so, in a couple days, we're going to figure out why that is. Maybe you have an educated guess by looking at the equation why this absolute value graph would be going a different direction than the rest. But we're going to start graphing using some of those clues in the coming days. So the vertex in this graph is at 2, 3. Again, vertex, that point right there. Domain, one more time, is all real numbers. We could plug in any x value we want in the world. The range is a description of what the y values are doing. So we're going to talk about y. Now notice again the y values, 1 to 2, up to 3, but then back down to 2, back down to 1. So this time, my y values are less than or equal to 3, because they stay 3 or under, essentially, when we look at our table and our graph. Okay, this is the type of graph we'll be doing tomorrow, and like I said, the more experience we get, the more we're going to take a look at some shortcuts or some clues that are in the equation that would help us graph. Thank you for your attentive note-taking today, and I will see you tomorrow.